Alright, in this video, I'm going to show you how we were going to be able to connect quadrant 4 to quadrant 3 while at the same time connecting quadrant 2 to quadrant 3. Now, to save time, I pre-fill the exact values for all of the angles from quadrant 2 and 4, then connect the horizontal lines and the vertical lines to their corresponding points, corresponding angles. So again, I pre-fill the angle measurements. So in quadrant 3 we have 210 degrees, 225, and then 240. Now, connecting from quadrant 4 and quadrant 3, so if we look at it, it's horizontal, so that means it's going to be the same y value. So I'm going to write here 1/2. Now keep in mind, since we're in quadrant 3, we were dealing with the bottom y values, so it's going to be negative. And then our x values, so quadrant 2 and quadrant 3, right here you see how they corresponds. Therefore the x values, again here's the x-axis, if they correspond, then it's going to be the same x value, which is negative square root of 3 over 2. So this will be the cosine value for 210, the sine value of 210. Now if you look closely, you see how this point, our x values, is the same value. So square root of 3 over 2, square root of 3 over 2. But at 330 degrees, it's on the right side, so the x value is positive. At 210 degrees, it's on the left side of the x-axis, so the x value is negative. And you see how the y value corresponds, negative 1/2. If you compare it to the one in quadrant 2, the x value is the same, as you can see from the vertical line, but the y value is different because in quadrant 2, the y value is positive. In quadrant 3, the y value is negative. So it's positive 1/2 up here, it's negative 1/2 down here. Once you see the pattern between quadrant 2, 4, and 3, including quadrant 1, then you see there will be a pattern. It's going to be easy for you to connect with the exact values. Now let's talk about 225 degrees, the one in blue. So I connected the horizontal line from here. So if it's a horizontal line, that means that it will have the same y value. So over here in quadrant 4, it's negative square root of 2 over 2. So therefore over here in quadrant 3, at 225, it will be exactly the same. Negative square root of 2 over 2. Now if I were to compare it with quadrant 2 and quadrant 3, that means it's going to have the same x value. So at 135 degrees, the x value is negative square root of 2 over 2. So at 225, it will be the same. So negative square root of 2 over 2. As you can see from the vertical line, it's going to be the same x distance. Now again, the x values on the left side is negative. The y values in the bottom is negative. So that's why cosine of 225 is negative square root of 2 over 2. The sine of 225 is negative square root of 2 over 2. Alright, so let's talk about the one in black, 240 degrees. So as you can see here, which I'm going to zoom in for you. So on my quadrant 4, it's 200 degrees, and quadrant 3, it's 240 degrees. So as you can see, I drew my horizontal line, so it's going to be parallel to each other, correspond to each other, so therefore the y value will be the same. If it's negative square root of 3 over 2 over here, then over here in quadrant 3 at 240 degrees, it will be exactly the same. negative square root of 3 over 2. And then, when I'm comparing quadrant 2 to quadrant 3, you see this vertical line? So they correspond to each other. That means that it will have the exact same x value. So at quadrant 2, 120 degrees, if our x value is negative 1/2, then in quadrant 3, 240 degrees, it will be the same exact x value, which is negative 1/2. So we have our exact values for 210, 225, and then 240. Now, so again, if you take a look at quadrant 4 and quadrant 3, you see how it has the same y value, and as you can see from the x value, it's almost the same, but on quadrant 4, it's positive 1/2, and quadrant 3, it's negative 1/2. So, when you're doing cosine of 300, it's 1/2, but when you're doing cosine of 240, it's negative 1/2. And the same thing here. From quadrant 2 to quadrant 3, the x value is going to be the same. So when you do cosine of 120, it's negative 1/2. When you do cosine of 240, it's also negative 1/2. But when you do sine of 120, it's going to be positive square root of 3 over 2. But when you do sine of 240, it's going to be negative square root of 3 over 2. So the x values are exactly the same. The y value is almost the same, except the one in quadrant 2 is positive because y values are positive. And in quadrant 3, the y value is negative because the y values here are negative. So now you see the relationship between quadrant 3 versus comparing to quadrant 2 and quadrant 4. Now, I wrote in the information for 180 degrees because it ties into when it's 0 or 360 degrees. As you can see, this is the x-axis, it's a straight line. So since this is a unit circle with the center right here, directly in the center, so it's the equal distance between the center to this point right here, which is a length of 1. So over here is the same distance, which is 1. Since it's a straight line, if that is 1, on the right side where the x values is positive, then on the left side where the x values are negative, then the x value right here would be negative 1. And since this is a straight line, it's at the same height, so the y value will be the same, which is 0. So when you're doing cosine of 180, it's negative 1. When you're doing sine of 180, it's 0. So as long as you understand the logic reasoning behind how I connect each exact values from each corner points, meaning from 330, 315, and 300 in quadrant 4, and the exact values and the coordinates, the angles, 120, 135, 150 degrees, when I'm comparing with quadrant 3, you'll be able to see the connection for the exact values here. So, if it helps you, you can draw the horizontal lines and the vertical line to see a better visual to see the connection. This is what I would do. Since I was not taught this, I had to figure this out on my own, and it actually made better connection for me. So maybe this will help you, since it gives you a better, clearer picture on how these corner points, these exact values are connected to each other, even though they have different angle measurements.